Ladies and gentlemen, my name is Dolf Gielen. I'm the Director for Innovation and Technology at the International Renewable Energy Agency. It's a great pleasure to address you on the occasion of the World Renewable Energy Technology Congress. And I would like to talk about global renewables outlook and the role of hydrogen for sector coupling in that context. So renewable power production and installed capacity is growing year by year. Here you see the global installed capacity over the last couple of years, and you see that we have reached a level of more than 3 terawatts, 3,000 gigawatts of renewable power. And most of the growth in recent years is accounted for by wind and by solar in gray and in yellow in this graph. We expect that this growth will continue, and in fact it even needs to accelerate threefold going forward in order to be in line with a 1.5 degree scenario with decarbonization by mid-century. And so with such accelerated growth, for a 1.5 degree scenario, we need to go from these 3 terawatts today to 10 terawatts renewable power by 2030 and even 25 terawatts by 2050. And so solar and wind become the bulk of power generation worldwide. And to make that happen, we need to work on the flexibility of power systems. We need technologies such as batteries, but also hydrogen production that have a key role to play together with changes in market design, changes in the system operation practices, and changes in the business models. So as the capacity of especially solar grows, there will be more and more days when the solar electricity that is generated exceeds demand. And you have to think what to do with that excess electricity. And one way to deal with that is to use it for the production of green hydrogen through water electrolysis. And then that hydrogen can be used in various applications. For example, in industrial applications. It can also be used for various heating energy purposes. You can also use hydrogen to produce derivatives such as ammonia, such as methanol, but there's now also attention for the production of, for example, jet fuel from hydrogen, or to use hydrogen for the production of iron and steel, and I'll come to that point. So today's world hydrogen demand is around 120 million tons. In our IRENA 1.5 degree scenario, that grows to more than 600 million tons by 2050, so a 5-fold increase. And we think that about 2/3 of that will be green hydrogen from renewable power, and 1/3 will be blue hydrogen produced from natural gas with CO2 capture and storage. We have also compared our results with those of other studies, and you see that it's fairly consistent. Leading scenarios suggest between 500 and 800 million tons of hydrogen production by 2050. And the bulk of that will go to industrial applications. That's what you see in the pie chart up on the right. Today, around 1% of all hydrogen that is produced is green and 1% is blue. So that needs to change radically, and especially green hydrogen production needs to grow significantly. So we need low-cost hydrogen production, which has 2 cost components. We need cheap electrolyzers, and we need cheap renewable power. You see the data about electrolyzer cost on the left of this slide. So today's cost is around $800 to $1,200 per kilowatt. We think that these costs can halve in this decade. And if you combine that then with cheap renewable power, 2 cents per kilowatt hour on the top right, then you get to total hydrogen production cost in the range of $1 to $2 per kilo. We need a massive ramp up of electrolyzers from 1 gigawatt today to 350 gigawatt in 2030 and even 5,000 in 2050. And that needs to be combined with 10,000 gigawatts additional renewable power generation capacity. So the investment needs for this part of the energy transition are indeed massive. So we assess the global potential to produce green hydrogen, and that is shown on this slide. So you see massive potentials in, for example, the Middle East, in Africa, in Australia. And these exajoule numbers you can compare with the global primary energy use at the moment of 600 or 700 exajoules. So it's like 10 times today's energy use. But to tap into these potentials, you need to trade hydrogen. We've done some model analysis. We think longer term that around a quarter or a third of all hydrogen will be traded globally. And we think that half of the trade will be by pipeline and around half of the trade will be via shipping. And we think that ammonia will become the main shipping option. And you see that already in a context that is relevant also for India, where, for example, in Oman, a lot of renewable ammonia plants are being built to supply India. So we developed an innovation outlook, renewable ammonia. We concluded that today's production costs for renewable ammonia are already below those of today's spot prices, which are very high for ammonia. And you see that there's a lot of activity. We expect at least 15 million tons of renewable ammonia capacity in operation by 2030. And the total pipeline is like 5 times that volume. And that ammonia is going into a range of applications. Of course, today's main market is for nitrogen fertilizers, but ammonia is also considered as a fuel for shipping, and ammonia is also considered as a fuel for power plants, for example, in Korea and in Japan. So a lot of developments in deploying hydrogen in this context. Then another example is production of steel. So steel production has grown very fast over the last decades. India is an important part of the global steel production, and its production share is increasing rapidly. So that raises the question, how can you produce clean iron and steel? Because today it's largely based on the use of coal. And there are a number of options that have been considered, but in fact, the key option that is currently on the table is the production of direct reduced iron or hot briquetted iron, which is then used in an electric arc furnace to produce steel. And there is a lot of activity now to develop this industry, with several commercial scale projects coming on stream in the coming years in Europe. But also elsewhere, there's a lot of interest. For example, a lot of the iron mining countries and companies are currently looking whether they can develop such activity. The potential hydrogen market is important. If all of iron production would change to this new route, you would need more than 100 million tons of hydrogen per year. So another market example is the production of sustainable aviation fuels. We think longer term that 2/3 of aviation fuel will be biofuel, but 1/3 will be e-fuels produced from hydrogen. And that is currently emerging because of legislation, especially in Europe and in North America. So a lot of plants are currently starting up that use green hydrogen with CO2 to produce synthetic aviation fuel. If we develop indeed 100 million liters of such sustainable aviation fuels by 2050, then we would need for this market around 14 million tons of hydrogen per year. So again, an important market opportunity. So in conclusion, there is a key role for hydrogen and hydrogen derivatives in the energy transition. And that is also something to be considered in an India context. And there is a lot of ongoing work in assessing these opportunities, looking into the integration of renewable power with these new types of industrial activities. From the IRENA side, we've done a lot of work on supply, trade and demand for hydrogen, as well as the enabling frameworks. And you can find all these studies on our website. That concludes my remarks. Thank you very much for your attention.